for chapter 6.2. We talk about the normal model. They give us this density curve, and for a normal model, it should be unimodal, which means one bump here. Should be approximately symmetric, which means from the middle to the left and the middle to the right, it should be approximately the same distance. And then the bell curve is this nice one bump there. If that is true, then you do have a normal model, and it's a good model. Center and spread of a normal distribution. If you have a smaller standard deviation, it's going to be taller. If you have a larger standard deviation, it's going to be shorter. They use that U-looking thing that is called mu. And what that is it stands for the center or the mean of the distribution. Then they use this sigma. What that stands for is the standard deviation of the distribution, the spread of your distribution. Note that the Greek letters mu and sigma are used for distributions and population data. X bar and S are used if there's a sample. Notation area. Here again we have this density curve. This dashed line here is our center, our mean. The area over here that is shaded is less than our 4. And so here they tell us it's a normal distribution. This is our mean. This is our standard deviation. Therefore, when they draw this, they start at 6, then 1 standard deviation, they add and subtract 2. 2 standard deviations, they add and subtract 2 times 2, which is 4. For 3 standard deviations, they add and subtract 3 times 2, which is 6. So the area under the normal curve above, the x-axis, and to the left of x equals 4 represents the probability that x is less than 4. The probability that x is less than 4 also is equivalent to the probability that x is less than or equal to 4, as long as it's a continuous variable. With your 4-step problems, I'm going to put a different sheet under here, and we're going to actually do a 4-step problem a little bit later so that you know exactly what to do each time when you are doing it. When you do your 4-step problem, please make sure you get into the habit of just numbering them 1, 2, 3, 4, because it's going to help you when you get farther into stats, because we continue to use it every time that we're doing this. And so if we take a look at this, here's a 4-step problem that I want you to do. And so according to the data from the College Board, the mean quantitative SAT score for female college-bound high school seniors in 2009 was 500. The SAT scores are approximately normally distributed with a population standard deviation of 100. What percentage of female college-bound high school seniors had scores above 675? Do the 4-step process. Step 1, write out that it's a normal distribution, because again, they told you that it's approximately normal. Then our mean, our mu, they told us was 500. And then our standard deviation, our spread, they told us was 100. What we're looking for here is that x is greater than 675, because they said it was above 675. The second step, you will find your z-score, which is how many standard deviations above or below the mean that your data point falls. So then we're going to take our x, which is our 675, minus our mu divided by our standard deviation. Then you're going to simplify it by taking the top divided by the bottom, and you're going to get 1.75. Then when you draw this for your third step, what you're going to do, again, you always put a title on it. When you draw your density curves, you draw your line, your x-axis. Your mu, your mean, is right in the middle, which was 500. Our standard deviation is 100, so we went 600, 700, 800. Then you go 400, 300, 200. Our label down here is scores. What we were looking for is where x is greater than 6.75 or 675, so we go over here to 675. Being it's greater than, we shade to the right. If you notice, 1.75 standard deviations is positive. Here, it's 1.75 standard deviations above our mean. Then what we're going to do is we're going to go to the back of our book, and we have to figure out what the 1.75 standard deviation goes with. So you're going to go to the back of your book. You're going to go down to the 1.75. Then we have to go across here until we get to the 1.7, and then the 5 is up here. So we're going to have to go until they intersect each other, which we get right here. You're going to notice that that's a 0.9599, but the back of our book is always to the left, and so we have to do a 1 minus that number, and then we end up with the 0.0401, which is approximately 4.01%. So the shaded part here is about 4% of our entire table or graph. Then you're always going to want to describe it in the context of the problem. And so about 4% of the college-bound female high school seniors has a score above 675 on their SAT.